Good morning guys. Today we are going to study Z transform, fresh module 5, right? Already we have studied the Laplace transform. I hope you remember third module, I think third module, right? So Laplace transform the purpose is just a refreshing class about just for 5 minutes right? So analog system or analog LTA system, okay? Analog LTA system analog LTA system, right? The analog system should be analyzed by some tool because we need to understand the characteristics of the particular system. Or analog system characteristics, stability, like rise time, peak time, settling time, actually control system. Okay. Now, system, analog system characteristics complete we may have to go for a tool that is called as Laplace transform. And one more thing, keep it in mind, this analog system can be represented mathematically by using differential equation. These things already we have spoken so many times actually. So, this differential equation is solve a tool on Laplace transform. That is the reason we say Laplace transform is useful for analyzing analog systems. Okay. So, Laplace transform, the pairs Laplace transform pairs. Pairs Laplace transform formula formulas Laplace transform the properties right. We talked about something called region of convergence, and the region of convergence gives you an insight view, right, about the characteristics of the particular equation, especially the location of the poles, etc., etc. Right. Within the region of convergence in the properties this exam this region of convergence in the properties or theory at like either Laplace transform or Z transform. Okay. So as expected, this Z transform is a close nephew or else close cousin of Laplace transform. How? Z transform is a close counterpart, like a close cousin of the Laplace transform. How do you call that? Look, this is analog system, right? Analog system, we can use a differential equation to represent it, and finally Laplace transform, which is a mathematical tool that is useful for solving the differential equation and hence can be useful for solving the, understanding the characteristics of analog equation. Because we have studied the sampling theorem. So once after sampling is over, we are discretizing everything in terms of digital or discrete. Okay, because we have discretized the signals as well as the systems. What is the reason of discretization that I have already discussed? Okay, so in short, what I am trying to say is now we are talking about digital clear discrete. I have already talked about the difference between a digital as well as a discrete. If you want, you can check out my previous videos. Okay, so in case discrete signals discrete system, we will be using difference equation to represent a discrete equation. We were using a differential equation. What is a differential equation? Dou y by dou x, something like this. Right? Difference equation is x of n minus 1. Last problem, last module. Discrete system will be represented by a difference equation. And how will you solve a difference equation? Difference equation will be solved by using Z transform. Z transform is nothing but a discrete version of Laplace transform. Z transform is nothing but a discrete version of Laplace transform. So as expected, whatever you can do with Laplace transform, same thing can be done by Z transform. So that's the meaning in the like Laplace transform use the properties use problems to solve and then finally the region of convergence nu vechittu Laplace transform region of convergence nu vechittu a systeminte characteristics ko nammal study cheyan patri. The same thing we are going to do it here. Ditto. In short, what I can say is ditto. Laplace transform, whatever we have studied, same thing applies in Z transform also. Okay, like we are going to study the properties. We are going to study an interesting thing called the region of convergence, and we are going to study ROC properties. Right? So this module is all about analyzing a discrete system by using Z transforms. So just as in the case of the Laplace transform, how do you define Z transform? So Z transform and the definition in the so the Z transform for a discrete signal x of n can be defined as it can be written as x of z. Okay, x of s and used to the Laplace transform. So we are using x of z here. Summation of, as expected, summation y, because we are talking about discrete sequences actually. So n equal to minus infinity to infinity x of n z power minus n. This is the definition of the, or else this is a formula for the z transform. Okay. The summations, if the summation starts from n equal to minus infinity to infinity, that means we are talking about a broad range of spectrum. Broad range of spectrum which starts from minus infinity to infinity. So this kind of system, or else this kind of Z transform, we will be calling it as two-sided. Negative side positive side. That's why we will be calling it as Z transform. The two-sided Z transforms in ஒரு பேர் வந்ததுனே. So they call it as two-sided Z transform, and in some books they call it as bilateral. That means both sides. Bilateral Z transform. ரெண்டு பேர் வந்ததுனே. Okay. So also keep it in mind, convergence, like Laplace transform, we were talking about convergence, right? Same kind of definition applies here as well. How interesting is this? Our ஒரு transform மாத்திரம் படிச்சா வந்து ஷேரிக்கும் பரங்கல மற்ற transforms okay easy ஆட்ட மனசிலாக்க முடியும். Okay, so here convergence, that is set of z values for which this summation is summation alone, for which the summation converges is called region of convergence of Z transform, right? So keep it in mind, this region of convergence will be an annular region in a complex Z plane. Look, there are two types of Z transforms that are possible. That is right-sided. That is a Z transform that can handle the right-sided sequence. Okay, so right-sided sequence means the meaning in the x of n is equal to 0 for all the values of idana meaning our origin left side ilulla ella values 0 1. So that means what does it mean? n0 greater than otherwise we will have finite values. That's the meaning. So in case this x of n is called positive sequence actually. So here one important note, like Laplace transform for a causal sequence, means what? Causal sequence. For a causal sequence, this is a tip on ROC is the entire z plane നമ്മൾ പ്രോബ്ലം പഠിക്കുമ്പോൾ ക്ലിയർ ആയിട്ട് മനസ്സിലാവും, ഇപ്പോൾ പേടിക്കേണ്ട ഒരു ആവശ്യമില്ല. entire z plane except at z equal to 0. ഒരു പ്രോബ്ലം ഇടാം. ഓക്കെ അല്ലേ? സോ ഇതിന് ഒരു എക്സാമ്പിൾ പ്രോബ്ലം ഇട്ട് നോക്കാം. Let x of n is equal to 1, 2, 2, 1 and this is the origin. Okay, so how do you write the z transform? Caps, okay, this the caps on x of z is equal to summation of this kando. This tells the signal is positive sequence. About causal sequence. Okay, about negative values illa. About n equal to 0 to infinity. So x of n into z power minus n. This is the z transform formula. We are going to apply on this. Let me go to the next slide. As you see, x of z previously a formula തന്നാണ്. ആ ഫോർമുല നമ്മൾ എക്സ്പാൻഡ് ചെയ്യണം. വേറെ ഒന്നുമില്ല, സമ്മേഷൻ ഫോർമുലയാണ്. ഈ സമ്മേഷൻ ഫോർമുല നമ്മൾ എക്സ്പാൻഡ് ചെയ്ത് എഴുതണം, അത്രയേ ഉള്ളൂ. ഓക്കെ, അത് എങ്ങനെ എഴുതാം? x of 0 into z power minus 0, x of 1 into z power minus 1, x of 2 into z power minus 2, x of 3 into z power minus 3. എക്സ്പാൻഡ് ആക്കി എഴുതി. അപ്പോൾ വാട്ട് ഈസ് x of 0? ഞാൻ ഇവിടെ എഴുതിയേക്കാം കേട്ടോ. ഗിവൺ സീക്വൻസ് x of n ഞാൻ ഇവിടെ എഴുതുന്നുണ്ട്, നോക്കിക്കോ. നിങ്ങൾ തന്നെ ചെയ്യണം കേട്ടോ പ്രോബ്ലംസ് അല്ലേ. അപ്പോൾ x of 0 എന്ന് പറയുന്നത് 1 ആണ് അല്ലേ. അപ്പോൾ 1 into z power minus 0 is same thing actually. So 1 plus 2 ഇത് 2 into z power minus 1 plus 2 into z power minus 2 plus last sequence ഇത് 1 into z power minus 3, right? So here the region of convergence. So this is the statement which I gave there, because for a causal signal, for a causal sequence, the ROC is the causal sequence on like given signal. This given sequence is a causal signal. So hence the ROC is the entire z plane except z equal to 0. I already statement tannarunnu, interesting fact. So how do you write this? So region of convergence, it is this one greater than 0. Okay, next thing is we are going to nammal idu padichadu causal sequence aanu, that is like a right sided sequence nu or pair undu njan paranju. Appo orappaittu right sided sequence nu or sequence undengil orappaittu we will be facing a sequence called the left sided sequence. Adu orappaanalle. So let us see one problem on left sided sequence as well, right? So let me go to the next slide. Left sided sequence. A sequence ആണ്. ഇതിനെ നോക്കി സ്പെല്ലിംഗ് എഴുതല്ലേ. സീക്വൻസ് ഇത് എഴുതാൻ കുറച്ച് ബുദ്ധിമുട്ടാണ്, അതുകൊണ്ടാണ്. Okay, left sided sequence. Okay, so here a left sided sequence x of n is the one where the x for which the value x of n is equal to 0 for all n is greater than or equal to n naught. Okay, but it has finite values for n0 lesser than or equal to 0. Okay, so this sequence, this sequence in a pair and the already നമ്മൾ പഠിച്ചിട്ടുണ്ട്, anti-causal ആണ്. Okay, so if the given sequence is an anti-causal sequence, ROC will be on the നിങ്ങൾ ലാപ്ലാസ് ട്രാൻസ്ഫോമിനെ കമ്പയർ ചെയ്യും. ഓക്കെ, ഞാൻ അവിടെ കൊടുത്ത എക്സ്പ്ലനേഷൻ എല്ലാം ഇവിടെയും ആഡപ്പ് ആവും. ഓക്കെ അല്ലേ? ഞാൻ ഇത് ഇവിടെ ഡയറക്റ്റ് ആയിട്ട് ഞാൻ കൊടുത്തു, അവിടെ പ്രോബ്ലം ചെയ്തിട്ട് ഈ ഇൻട്രസ്റ്റിംഗ് ഫാക്ട് ഞാൻ കൊടുത്തു. ഇവിടെ ഡയറക്റ്റ് ആയിട്ട് കൊടുക്കുന്നുണ്ട്. ദ റീസൺ ഇസ് ഇത് വേറൊരു അപ്രോച്ചാണ്, അത് വേറൊരു അപ്രോച്ചാണ്, പക്ഷേ കാര്യം ഒന്നാണ്. സോ ഐ സജസ്റ്റ് യു ടു ലുക്ക് ദീസ് വീഡിയോസ് ആസ് വെൽ. മേക്ക് എ കമ്പാരിസൺ ബിറ്റ്വീൻ ലാപ്ലാസ് ട്രാൻസ്ഫോം ഇസ് ട്രാൻസ്ഫോം. അപ്പോൾ ജീവിതത്തിൽ ഒരിക്കലും മറക്കില്ല, അതാണ് അതിൻ്റെ ഐഡിയ. Okay, so ROC will be on the entire z plane excluding z equal to infinite. So let us verify this one by a problem 1 comma 1 comma 2 comma 2 origin. Okay, this is origin. So what is the formula? X of z is equal to summation of n equal to minus 3. This is 0 ആണ് 1 ആണ് 2 ആണ് sorry minus 1 ആണ് minus 2 ആണ് minus 3 ആണ്. അപ്പോൾ n equal to minus 3 to 0. So x of n into z power minus 1. How will you write this? How will you expand this? X of minus 3 z power 3 plus ln z3 plus x of minus 2 z square plus x of minus 1 is where on like a formula expand x of 0. So ultimately when you write this equation, z cube is a square 2z plus 2. So ROC modulus of z according to this condition, modulus of z is lesser than infinite. Explanation in I told you the integration should not blow up. The integral value should not blow up means what the meaning of that it should not reach infinite values. Same thing is here. Now this plus plus this z square this is z square. Plus like this particular equation x of z will not blow up only on this condition. Right? If it is lesser than infinite, very sure this summation will give me a finite value. So Laplace transform and approach same ആണ്, Z transform and approach same ആണ്, ഒരു വ്യത്യാസമില്ല. So അവിടുത്തെ വീഡിയോസ് ഇവിടെ അതിന്റെ കോൺസെപ്റ്റ് ഇവിടെ ഉറപ്പായിട്ട് യൂസ് ചെയ്യാൻ പറ്റും. ഓക്കെ അല്ലേ? അപ്പോൾ നമ്മൾ ഇതുവരെ നോക്കിയത് whatever we have studied so far is like right-sided sequence as well as left-sided sequence. So if there is a sequence called right-sided or left-sided, very sure we will be having both-sided. So we call that kind of signal as double-sided sequence. Right? About double-sided sequence, what does it mean? Left-sided sequence undavum, right-sided sequence undavum. That's sequences. ROC engana undavum nammal nokkam. Nammal avadeyum padichittundu Laplace transform padichittundalle. I mean side by side you compare cheyidale you will be getting a lot of ideas. Okay, so I suggest you to do that. So let's see this. A signal is that has finite duration. A signal that has finite duration in both the left side as well as right side is called as double-sided sequence. Simple. So ഇതിന്റെ ROC എങ്ങനെ ഉണ്ടാവണം ഒന്ന് മൈൻഡിനെ ഒന്ന് കത്തി നോക്കി, മൈൻഡിനെ ലൈക്ക് സ്ക്രാച്ച് ചെയ്ത് നോക്ക്. ROC will be the entire, because it is a mix of both alle. So the ROC will be the entire Z plane, of course, except at Z equal to 0. Why? Because adinte final equation eduthu nokku z power minus something undavum. Appo like idile like some values 0 like vannu kayinjal it will become infinite. That will make the x of z to blow up. We won't be getting a finite summation. That means the summation won't converge. So Laplace transform different, I mean adinte explanation aanu. Laplace transform il thanna same explanation ibadeyum idavanu fix avunnundu alle. So idu or condition. So if it is a double-sided sequence, ROC will be the entire Z plane except at Z equal to 0. The second condition is, and also the ROC will be modulus of Z lesser than infinity. Okay, so let us try to do a problem on this. So let x of n, example 3 x of n be 2, 1, 2. So here let us see that this as the origin. This is the origin. Okay. So both, I mean, since it is having both sides, we call this transform as both-sided transform or double-sided transform. So the equation will be n equal to minus infinity to infinity. പക്ഷേ ഇവിടെ സ്പെസിഫിക് ആയിട്ട് നമുക്ക് റേഞ്ച് കിട്ടി, റേഞ്ച് ഉണ്ട്. അതുകൊണ്ട് ഞാൻ ഡയറക്റ്റ് ആയിട്ട് എഴുതുന്നുണ്ട് n equal to -2 to -1 x of n is a power -n. How do I expand this? Same procedure. Do not use caps, okay? Meaning that x of -2 is z square plus x of -1 is x of 0 plus x of 1 is the power -1. I can write this as 2z square plus z power 1, then x of 0 1 appo 1 plus 2z power -1. So what is the ROC? Region of convergence is between 0 to and lesser than infinite, because of these two conditions. So lesser than 0 ആണ് first condition, lesser than infinite ആണ് second condition. ഈ equation എടുത്ത് നോക്ക്, x of z equation എടുത്ത് നോക്ക്, ഇത് 0 ആയി കഴിഞ്ഞാൽ, suppose if it is equal to 0, that makes x of z infinite. Again ഇത് എടുത്ത് നോക്ക്, infinite. അപ്പോൾ ഇതിൽ suppose z, ഈ z ഉണ്ടല്ലോ പോസിറ്റീവ് സൈഡിലുള്ളത്, ഈ പാർട്ട് infinite ayal, again that will blow up and x of z will be infinite. So that's the meaning actually. So x of z will be finite except at this value. So that is the reason the region of convergence will be between 0 to infinity. So that's it guys. So today's class is over, and tomorrow we will be studying about the properties of Z transform, where in the properties of Z transform and the properties of ROC. ഈ രണ്ടും ഒറ്റ ക്ലാസ്സിൽ തീർക്കാം പറ്റുമെങ്കിൽ ഒരു പ്രോബ്ലം എന്തെങ്കിലും ഇടാം. Okay, thank you very much.